Hello everyone. We are team 13 and in this team me, Basu and Biswa is there. In this we did multi-level and multi-model classification and for that we used Spacey module pre-trained on large amount of text data, namely Wikipedia and articles, so that we can understand the meaning between the words and it can be used for the labels. Extract the labels from the description given to us as all the description doesn't have the exact label, exact name of the label which we have. So first of all, downloaded the image data in image data new npy. We downloaded the images from the link given to us and stored that in our npy format so that it can be further used, and during the training we do not have to download it again. So in this image data .np.log we downloaded we loaded that data downloaded from the description given or links given to us. So in this, first we assign the labels and 20 labels given to us, namely the written there. So we first of all we assign them, and in the block 125 we took the trains and final, and these are the trains and final consisted of all the data, all the description per image to given to us, and per image there were 50 descriptions, so 1000 images, and per images there were 50 descriptions. So we extracted all the labels, all the description of particular images, and assigned made a list out of that, and in every list the data. And in 113 block, uh, in 113 block we remove the punctuations and stop words from the data we extract description we extracted from that, and now we are left with the words, particular words. And in the 115 block we for every we went through every word of the list, and for list we counted that order maximum amount of words which are occurring, and took the top 10 words and assigned it to the word list final dictionary. So in word list final dictionary, for every image we have the top 10 words from the description which we have, and from but the words we extracted from the word list final and during the word operation described earlier was not enough, because some words were not present there. For example, person's name and everything details were given, but person was not written there. So we were missing out that label, and similarly to other labels we were missing. Animals were written, but not a cow or cat was written. So to overcome that, we also took the pre-trained model of Google, that is ImageNet, trained on large amount of data, large amount of image data, so that we use that on a given images and extract the data from that image, and assign the label to extracted features, and then later we combine the both the labels extracted from text and image and get the final. So in this block 119, in block 1117 we use the pre-trained image data, and in 119 it is we are in a for loop we are feeding every image to the pre-trained model by doing pre-processing on that by setting the image dimension and everything, and then we extracting the label from the images and assigning it to the label, temporary labeling, and then we for every image we are assigning that label to image labels in a dictionary. So now we have two dictionaries. Word list final obtained from the word list obtained from the word processing, and another is image labels obtained from the pre-trained model. Now what we did is to combine these labels, and after combining these labels we had a uh, dictionary for every word, for list for every image present, and from this we'll compare in 90 block 90 we compared both list. In block 92 we compared the list available to us by uh, performing above operations, and we compared this with the image labels we had with us, 20 image label we had in our hand. And after comparing we also compared the labels we extracted using a Spacey module, and they calculated a distance between them, and we calculated if the percentage is greater than 69%, then we assign it to the assign it as label, or else it is not assigned as label. And there is also one block if TV or monitor is there, and then we assigned it as TV or monitor. It was there in a final level dictionary or list we obtained, because the label we had was TV slash monitor, but in the descriptions it was written either TV or monitor, so it wasn't matching, and we couldn't afford to lose that, so we made another if block to compare if there is any word with TV or monitor in the description, and we assigned it also to the label of particular image.
Okay, thank you, Maninder. From here on, I will describe the multi-level classification and image description. So, as you can see, the labels that Maninder extracted, I read that labels and gave that in the model sequential model, in which I used four convolutional layers, and after each convolutional layer, one batch normalization, one max pooling, and one dropout layer. And in last, I used one flatten layer and two dense layer and one output layer. And in compiling, I used binary cross entropy and Adam. So the model that this is the summary of the model. The input shape was 240 cross 240 cross 3, and output is 20. From this model, the accuracy is pretty much low, 21.12, as you can also see from the training and validation arrow here for the loss of the training and validation and the accuracy of training and validation. So I moved from here to some inbuilt model, the VGG16 model. In the VGG16 model, I took the weights of the ImageNet and input shape 240 plus 240 into 3. And by training from the VGG model, as you can see, the I got the accuracy around 56.87% and the training and validation loss in this case. So finally, the since the accuracy is pretty much good than the normal sequential model, so I used VGG models, and I predicted using the VGG model. So as you can see, the image of the X test 0, the data I divided into train and test. So this is the test data, and the prediction is bicycle, car, motorbike, and person. So since the accuracy is not pretty much high in this model, also that's why it is predicting pi cycle also. Okay. After this, I is the image descriptions. So in image description, I used pre-trained model ResNet 50 for the feature extractions. I have taken the inputs of the ResNet model and the last second layer as the output of this model. The input shape of this model is, as you can see, is 224 cross 224 cross 3, and the output is 2048. Then after that, I loaded the data and did some pre-processing for the text data. For that, I loaded first the descriptions data, all the descriptions that were given, and took the top five sentences of from every image, and then created a vocabulary out of that sentence. And after creating the vocabulary, I encoded the every sentence into integers. After encoding that into integers, I what I did is I made for input for the LSTM model. In For making the input of LSTM model, I made in sequence and out sequence. In sequence, the image is there, and then the another word in just after the image, and out sequence will predict the uh, word that comes after that word. After predicting the out sequence, the in sequence will again take the predicted word, append that in sequence, and then predict the out sequence word. So by using this, the length of the total image that I got is 54,185. And then I used LSTM model. Here I used the LSTM model uh, for the predictions of the descriptions, and I trained on that, and I got the accuracy around 75.65% is the accuracy. And after that, I predicted for some image data, like you can see here. For this image, it is predicting very well that a car is at a station. For this image, it is not predicting so well that like a small bird sits on a bird hand, but this is the human hand. So simply accuracy is low. It is giving sometimes wrong words. But in another images, it is giving very well. Like here, a cruise ship at water. Um, they hear black dog, so a black dog is running through the grass, and ship, so a ship within a threshold goes. So this is all. Thank you.